All right, so thanks to the organizers. Matt is not here, but yeah, so thanks for the opportunity to read this paper. So I'm going to discuss a paper by Dan Millimet. I was aware of Dan's work, but I'd never met him, so there's another great opportunity here. It's about rethinking composite indices. This is a huge paper, so there's a lot going on in the paper. Regardless of what I say, if you're somebody who has a latent variable problem, which is I think just about everybody, I encourage you to engage with this paper, especially as it progresses, because it's brand new. You know, I'm going to start super broad. I'm not going to cover everything in the paper, just because again there are so many different cases here. We've got different standardizations, we've got different models, we've got different applications, and I'll try to focus on you know, where I think there's the most to gain from this discussion. So super high level motivation here. You know, in economics, we have a latent variable problem in most settings. I think about this in two kind of ways. You know, there are unobservables in our regressions that we often have some idea or some intuition as what they might be, ability bias being the most common one. But more generally, we have, you know, some constructs, theoretical constructs that we think really matter that are not perfectly measured in data. So utility is a good example. Human capital, health for this crowd. You know, when I open the Framingham data set, there are hundreds of health measures, right? What is health if I wanted to go and estimate the Grossman model? It can't be all of those things. I have to find a way to reduce that dimension. Social capital is one that I've been thinking about a lot lately. In particular, trust. What is trust? You know, what is social capital as it relates to trust? And these are kind of big picture questions that economists are thinking about a lot. And so, you know, we want to think about how to construct empirical measures, empirical proxies of these latent variables in sensible ways. So in this paper, we're going to stay in this setting here, which is very straightforward. There's a latent variable x star that we think influences some outcome y. I should say that this is a cross-sectional relationship. Okay, there's no time dimension. Static relationship. X star is the latent variable. It affects some outcome y through beta, and there's some covariates w. So Dan and his co-author are thinking about both beta and delta here as, you know, interesting parameters, and we want to know, how do these parameters change, or the estimates of them? How robust are they? How consistent are they? For different choices of how we aggregate, okay? So that's the basic idea of the paper. I'm going to focus on beta because I think that's the majority of the writing in the paper. So instead of observing x star, we observe measures, or as Dan calls them, manifest variables, z1 through zj. And x is going to be our proxy index. That is a function of these manifest variables, and g is going to be what we're choosing here. So the index creation problem is going to be to choose g, so that x is a useful proxy for x star in equation 1. And where useful here is you know, implying consistency and unbiasedness of the estimates of beta and delta. He says we're going to focus on linear indices here because of the literature of the form that you see there with the parameter lambda. And the paper is really kind of a blend of how to do this and some novel econometrics. And as you'll see, you know, later, coming from my perspective, I actually wasn't clear how much of it was how to and how much of it was novel. And so, you know, I think that could be clarified a little bit as a first comment. They're going to consider two measurement models, systems here. One is what he calls the reflective model, which frankly was the one that I was aware of. I was not aware of the other one, the formative model. But in the reflective model, you've got x that is producing these measure manifest variables z, and there's some measurement error u. In the formative model, there is a relationship where x star, the latent variable, is produced by these manifest variables. And measurement error here is in the sense that we don't observe all of the relevant manifest variables. variables, okay? And he talks about a little bit how the measurement error structure is essentially the same, because if you don't observe all of the measures, the relevant measures for X star, then you're going to get these lambda stars that are incorrect. I'm going to choose here to focus on the reflective model. It seems to get a little bit more weight in the paper. I think one thing that would help the reader is to kind of know why one would choose one or the other. It wasn't clear to me. Okay, and then we have a huge set of index choices. So how are we going to construct this index? Principal component analysis is going to take up its own section of the paper, and I will preview the results. Don't use PCA. That is one of the central findings here. And then we have a variety of others: equal weights, mean z-score, partial least squares, exploratory factor analysis, and then outcome-driven approaches. And that actually includes a few like nonlinear regression, IV, and things like that. And we're going to evaluate all of these methods through simulations where we look at root mean square error and bias. He also has a replication of a fairly well-cited AER paper that's using principal component analysis. He's also going to do an application to a very interesting question of how Republican vote share in congressional districts is a function of the health of those districts, the health characteristics of those districts. And the results here, number one, these are my words, not his, but please stop using PCA. He says in the paper, you should think long and hard about using PCA. I'm going to go ahead and say that the conclusion is that you should not use PCA. Outcome-aligned approaches seem to do really well. In particular, just throwing those manifest variables into the regression and thinking about it that way. Index measurement causes bias in all of the coefficients, so the beta and the delta. Measurement error is going to be non-classical, and attenuation bias is not guaranteed. So we don't really know which way the bias is going to go. He has a nice quote here that I think the bottom line is that what you choose to do with this problem is an identification choice. Okay, so this is a fundamental problem. And it's super helpful intuition. So in my most recent revise and resubmit, this is from referee 2 that said, hey, why don't you think about using principal component analysis? And when I was writing the response to this, I can't cite Dan's paper yet, but it was very timely to have this kind of intuition as a response. Okay, so I've basically told you the setting. The regression analysis that we're interested in, the structural equation of interest here is the y is a function of the latent variable x star. There is a difference between the count of measures that we do observe j and script j there, which is like all of the potential relevant variables. And then he's going to kind of, at this point, start to do everything in a lot of different cases. One is linear standardized index here, where we standardize the manifest variables, and then there's the non-standardized version. Some guidance on the standardization would be helpful here. My understanding is that when we standardize the z's, we're normalizing the variance of the z's, and that's going to have some restrictions that will be placed then on estimation of the factor loadings, if that's something that you are trying to do. And my main comment at the end is that I think that is something you want to be doing. And so some of the papers that I'll cite at the end do not choose to, or they choose not to standardize. And so I think some guidance here would be helpful to the extent that you want this to be the kind of how-to paper. Okay, so I've talked about the reflective model. This, in my view, this is a fairly restricted reflective model, because we're just going to say that we're essentially normalizing the factor loading on here to be 1. There's no mean in the equation, and then you've got your u, which is the measurement there, and he's got this nice picture of kind of a DAG that says
how the U's influence the manifest variables and how the manifest variables affect X star, and then that goes to Y.
A number of assumptions here that are going to be maintained is that the measurement errors have mean 0, the variances are going to be specified. Importantly, we're going to have independence across, so the covariance between two different measurement errors across the manifest variables is going to be 0. The measurement error is going to be uncorrelated with the latent variable of interest. In the structural equation, so in the Y equation, the error term is going to be uncorrelated with the measurement errors, and then the covariates W are going to be uncorrelated with the measurement errors. And under those assumptions, what you're going to get is an index error,
which is the difference between the latent variable and the proxy index. And so that difference under those assumptions is going to be a function of these loadings in the linear index times the latent variable and the measurement error there. And so one thing I'll say at this point is just that we're not really making assumptions at this stage about the scale and location of the latent factor. Okay, we're keeping that general, and it has these properties. The data generating process is the structural equation here. Y is a function of the latent variable. He has set this up so that we're in a scenario where OLS is going to give us unbiased and consistent estimates, with the exception of this indexing problem, this latent variable problem. Okay, so the probability limit of the OLS estimator then is going to equal the true beta times this term. And if we make some of the classical measurement error assumptions, this is going to collapse dramatically to what he's calling the reliability index, which is the variance of the latent variable divided by the variance of the index. And it becomes much simpler because a number of these terms in the covariances would drop out. Okay, so we have a lot of indices that we could potentially create here. He's going to spend a lot of time on principal component analysis. I'm actually not going to I'm not going to do the math. I don't have time to do the math on every single one of these. But he spends a lot of time on principal component analysis, and so I want to emphasize this. The PCA here is going to be this linear combination of the manifest variables, where the weights are going to be chosen to maximize the variance, subject to this unit norm restriction. And the weights here are, maximizing the variance. The key intuition that comes out of this is that maximizing the variance is not necessarily what you want when you do this. You want to maximize the signal to noise ratio, right? And so if you imagine that there is some manifest variable that is highly variable, that has very little to do with your Y variable, then PCA is going to give that a big weight, and it's not really informative. It's more noise, not signal. And so in this environment, then you're overweighting noisy indicators, and the measurement error here is going to be non-classical. It can be in any direction, and the convenience of PCA is not going to be neutrality on these questions. So from the theoretical perspective, we don't want to be using PCA, and so he's going to, and that will be borne out when we look at the simulations and the applications. I'm going to fly through these because I don't have enough time, but he thinks a lot about other indices that we could create, one of which being just unit weights, so we're going to weight every one of the Z variables equally. One, for the health crowd, this is something that we see a lot, right? So if you think about the depression score, that PHQ9, that should be PHQ9, I think. These, depression, mental health scores are often just the sum of individual questions, right? So we're treating them equally. The CHAD score is another one in atrial fibrillation. So there's a risk of stroke from different for different treatments. And so the CHAD score is literally the sum of whether or not you have hypertension, if you have chronic heart failure, if your age is above a certain threshold, and whether or not, what is D? Anybody? What's D? I forgot. Diabetes. And S, whether or not you've had a stroke in the past. And so, in the medical field, they use these kind of unit weight rules quite a bit. So I think there's a lot of application for your work there. Also, he considers the mean Z score. So here we're standardizing the Z variable and then averaging those. This is common in the economics literature as well. He also considers partial least squares, where we're again thinking about a linear index here, x PLS, where the weights are going to be chosen as to maximize the covariance between the z's and the y's. This is a new step here relative to PCA and the other ones that I talked about, because we're incorporating y. There's a little bit of supervision, to use a kind of a machine learning term there. And then he does a couple others that I'm honestly just going to omit: exploratory factor analysis and nonlinear least squares. But the Lubotsky and Wittenberg 2006 paper has a nice solution to this as well. What if we don't want to create an index? What if we just include the manifest variables in the main equation here and then sum their coefficients? OLS is good at giving relative weights as they relate to y. And so if we sum those coefficients, it turns out that this is going to be a really nice solution, a surprisingly nice solution. And to quote the paper, this has actually gone somewhat unnoticed by applied researchers. So maybe we should consider this. It's only going to be valid in the reflective model with classical measurement error, which is something I'm going to come back to in my comments, but it has some appealing properties. The summary here is that replacing the latent index, the latent construct, with a proxy index is going to lead to biased estimates. Okay, so there are a lot of probability limits in the paper that show that very clearly, consistency problems. The index error is going to be non-classical, and so we don't know which way the bias is going to necessarily go. So there's not a perfect solution. He's going to do a set of simulations. And the simulations here are meant to capture all of the kind of different cases that I've talked about so far, in addition to others. He's going to specify this equation that we've seen, the structural equation, and then we have a factor model where now we actually have a factor loading in the equation. So that was a little bit strange because I hadn't seen that yet in the paper. And then he's going to make a variety of assumptions about the sample size, the coefficients delta, alpha, and beta, the latent variable itself. And I'll make a comment here too. This is, we had made no assumptions about the latent variable itself up to this point, but now we're making assumptions about its mean and its location and its scale. And so I'm going to come back to that in a minute. The factor loadings omega here are set at different levels. We're going to have different assumptions about the variances of the measurement error, but these are always going to be 0 in the off diagonal. And then the number of manifest variables that we're actually going to consider. He's going to evaluate the different index choices on a variety of measures, bias, root mean squared error. And I'm not going to talk about every one of them, but he's got a lot of different cases. Okay, so for example, what if we observe the true X star as like a benchmark, but then OLS including the manifest variables in the individually in the regression, using PCA with and without standardization. A lot of cases to get through here. Rather than go through every number in the table, for time's sake, I'm just going to summarize the simulation results by saying that this Lubotsky and Wittenberg approach, where you include the manifest variables in the structural equation and add up the the betas is a highly recommended approach from what you can look at the simulations in the paper. Partial least squares, interestingly enough, which is like very common according to the paper in the life sciences. I was not aware of that. Does well when the manifest variables vary significantly in scale. Okay, so when you have a situation where some of the z's are on very different scales than others. PCA basically never wins, never seems advantageous. And when you have noisy manifest variables, the mean z-score seems to do quite poorly. And so then he goes on to do a couple of replications, or a couple of applications, I should say. One is in overconfidence in political behavior. So this is from Ortoleva and Snowberg in the AER in 2015, where they're trying to say, how overconfident are you in your beliefs? That's a latent variable. And how much exposure do you have to Fox News or other kind of media? And those are both latent variables. The paper in the AER uses principal component analysis to measure those or to capture those. And the conclusion that this paper finds is that, those are remarkably stable, but when you start to incorporate some of these other choices for index construction, PCA looks quite attenuated. And then they do an application where they think about the change in the Republican vote share from 2020 to 2024 at the congressional district level as a function of health characteristics aggregated to that congressional district level. And they try, again, a variety of indices. And so there are lots of different health measures at that level, right? So you can think about breast cancer deaths per 100,000 females, for example, binge drinking, a variety of different health measures. How do you aggregate those to the extent that you want to? And these are their results when they, again, let me give you the going so fast, the regression equation. They want to know, how does this health index affect the change in Republican vote share? That's the goal. When they do that with a variety of different index choices and with an increasing number of manifest variables. Again, I said that there are tons of health variables. The conclusion here is that the Lubatsky and Wittenberg is fairly stable across these choices. Whereas something like the mean z-score and the equal weights index, they kind of bounce around. They're not very stable. And the PCA index, unsurprisingly from the theory, is the most, I think it's consistently just attenuated and small. And so, again, PCA and some of these kind of unsupervised approaches are not that appealing. Okay, so in the 5 minutes I have left, I'm going to think about some comments here, and I want to take a quick aside and tell you why I think I was asked to present this paper, because it might not be obvious. And so I just 2 minutes about my background. So when I was a graduate student, I was just really motivated. I was reading some of these seminal papers. I really liked the kind of Becker and Murphy framework, and I really liked the Michael Grossman framework. And I thought, I want to do something ambitious, and I want to estimate a model where I think about how is it that someone who's addicted to something changes their behavior when they receive information about their health. And so in relative importance, here's me. In relative importance, here's me. And so in my dissertation, I got access to the Framingham Heart Study data, and all of a sudden I thought, oh wow, I've got a real latent variable problem, right? Because I want to estimate this big model, but I observe hundreds of health measures, And if you think about the Becker-Murphy framework, there's this really important stock of addictive capital. Well, what is that when you open up your data set? I don't know. So I chose to use principal component analysis. And that got the dimension of all of those things down to one simple index. And I took that index and then I put it into the structural model. And I got a PhD, and it was great. Okay, so then I submitted my paper, okay? And the guy handling the paper was this guy. Okay, and I'm gonna give you the sanitized version of what he wrote to me, okay? He wrote to me, the sanitized version was that PCA is not appropriate, okay? And so what I should be using instead were some of the things that he was developing in the context of cognitive and non-cognitive skills, okay? A child's skill level is a latent variable. Test scores are kind of an imperfect proxy for that. And I'll say that, you know, this paper in Econometrica that came out right after I submitted my paper was, you know, this is a really difficult paper. So this is a paper that spends, you know, maybe the first 30 pages kind of trying to convince you that normality assumptions are not going to be crucial to the identification, because I think that's an important bone for him to pick at. But I think more generally, the nice thing about their framework was that rather than say, oh, we've got this latent variable, and we think it influences Y, the latent variable itself is the object of interest in these papers. Okay, so so like cognitive skills and how they evolve and how parental investments affect them is itself an interesting and important question. And so they build this measurement model that's actually nonlinear in its relationship between the latent variable and the measures. And that helps them to think about things like dynamic complementarity. So if my skills today are high, how does my skills today affect the growth of skills tomorrow? So my first comment would be that I think that there is an opportunity here to connect this large empirical literature to a lot of the, you know, kind of standard, like a lot of the kind of well-received knowledge in other parts of economics, where, you know, PCA is not allowed, right? PCA is something that we discourage. And so I would, just as a suggestion, I think it would help, you know, forgetting about the dynamics, forgetting about the kind of panel nature of the data that they were using. I think it would help to just start with a slightly more general reflective model where you've got factor loadings that need to be estimated from the data. And so this is a simple framework where I've made a lot of the same assumptions that the paper has made, but then in 5, I'm normalizing the first manifest variable, the scale to be 1. And so in the Heckman context, that would be like test scores, right? Where we have some kind of notion of the scale of that. And then in your simulations, you know, you're not afraid to fix the location of the latent variable. So I don't see why you can't set it to 0 as well. That's what Heckman does. And then if you have more than 2 measures, it's actually straightforward to identify the factor loadings just from ratios of covariances. And so if you get those alphas, you can then pretty straightforwardly estimate both the measurement system along with the structural equation in a joint framework. And it strikes me as that would be a nice place to start, as opposed to a place where we say, you know, let's construct this index in an unsupervised atheoretic way. But that actually comes, I think it comes down to, like, what is the literature you're trying to connect to? And so the audience, for me, wasn't always clear. It also struck me that it wasn't clear to me how the simulation actually works if it's the case that we fix all three of the factor loadings to 1 and fix the mean and the variance of the latent variable, and we assume uncorrelated measurement errors, it seemed like there wasn't a free parameter there to get results from the simulation. So I'd like to see more, just flesh that out more. And then one thing that I'll say about that literature is the skill literature that I think you should, one of the reasons I think you should really take it seriously is that Agostinelli and Wiswald in the JPE that's right now, the most recent version of the JPE, said, you know, Cunha, Heckman, and Schnock was a big leap forward, but they're normalizing twice in their model. And they're assuming these uncorrelated measurement terms, the Z's. And in fact, when they allow for some correlation across the measures, they find that the degree of complementarity is significantly attenuated relative to Heckman's econometrica paper. And so, and Heckman's the editor on this paper, right? So I think this is a literature that you should at least engage with, because it is moving in a direction where the correlation of the measurement errors is the fundamental issue. And then finally, I know I'm out of time, but I would just say that the audience was not always clear to me. I think there's clear need for this paper because obviously in the AER we're still using principal component analysis, but I think there's an opportunity here to connect different parts of the economics literature. So I'll stop there.
If you indulge me 1 second, I want to go on my rant, and so I want to, not ranting against Michael, but since, is this touchscreen? Is that what's going on?
It's selectively touchscreen.
All right, maybe I won't be doing this. Can I open up a new tab? All right.
You should be able to with the mouse.
I don't see the, I don't see a
There
green.
you go.
Oh, there we go.
Yeah, you share it.
This is probably going to take way too long. So while I'm doing this, I'll say the benefit of being a full professor is that I write papers for me, and that can make it. Sometimes they don't always come across the best, yeah, I don't really know who I'm pitching it to, so that's definitely something to think about. Yeah. I don't know if I can make that big enough, but you can. Oh, did I close? Anyway. So that quote from Grelicus's paper in the AER on, it's called something like econometrics or econometricians and data, the uneasy alliance or something like that. That's the quote that that's my research agenda, I guess, of the last couple of years. So really the last kind of sentence about, in the Grelicus quote about how there's two data generating processes. There's the population data generation process that's driving the economics behind what we're doing, and then there's the data generating process for the data that we're actually using. And we think a lot about the first one, and we don't think enough about the second one. And that feeds into exactly what Michael was saying we should do even more in the paper, is think about the structural stuff with Heckman and these other papers, and bringing in the measurement problem, the measurement model into the economics model that we're gonna wanna estimate. And so yeah, that's my big rant. I think my preach for my students and things like that is that oftentimes we see the data first and then we write down the model that we can estimate because we already know what data we have, instead of writing down the model that you think is the true model that you would want to estimate, and then you take it to the data, and if you don't have the data that maps to everything that you need, then you start relating the data that you do have to those things that are in the model. And so that's what we're trying to do in this paper in the context of indices. is think about the Z's that you actually have. And instead of just running an OLS regression and saying, I'm gonna regress Y on Z without thinking about it, then it's hard to think about what the econometric implications are. But if you write down the true model that you think exists with X star, and then think about how X star relates to what you do see in the data, the Z's, then we can think more constructively about what are the econometric implications and how do we exactly want to use those Z's in the most straightforward way. Yes, I want to definitely thank Michael. The paper is definitely just starting, and so we still have a ways to go, and so I appreciate that it wasn't necessarily the easiest thing to read. I will go to his slides. This was also one of these papers that, like, as we got into it, you realize there's a big literature on everything, and so what motivated me to do the paper originally was thinking about PCA, and I didn't think PCA would be very good, and so I wanted to think more about it. But then it kind of, there's different literatures have different disciplines have different norms about what their kind of preferred index is, and so then the paper's kind of gotten a little unwieldy because of that. But I do want to just kind of stress this part, and it was one of your comments about thinking about when would you want to use one of these versus the other. So I've never seen these terms, these are not my terms, reflexive and formative. I've never seen them used in an econ paper, but they're all over the place in other disciplines. So thinking carefully about which model is actually right, I think is a big deal, and it's certainly not obvious. The reflexive model, I think, is how we learn measurement error, and so that's how we traditionally think about these things. But the formative model, I think there's certainly instances of it. One of them is in the replication that we're doing. One of the indices that was in that AER paper was media exposure. And then the Z variables were, do you read the newspaper? Do you watch Fox News on TV? Do you read blogs? And all sorts of stuff like that. Well, that's definitely the formative model. Your total media exposure is an aggregate of all of these individual types of exposure that you might get. Another easy example of formative one would be like assets or wealth. Your total assets is obviously an accumulation of all of your individual assets. And so it's not going the other way around. Wealth would be the same sort of thing. So I think there's definitely a lot of variables that fit in that. One of my kind of questions I would like to hear is how we should think about health in our application in the paper. So a local measure of area public health is, which one of those seems more appropriate for that? Is there, is the health of a given area the sum of the prevalence of diabetes and the prevalence of obesity and all sorts of these other things? Or is there an underlying health that then is driving these individual specific measures? So I think that's kind of an interesting question, because what comes out of the simulations is the different indice approaches work differently in these two cases. And so thinking about which one of those is kind of the true measurement model, I think then affects the way you were going to approach the data. I don't think I have much, who we're pitching it to. I think that I definitely need to think about. I'm open to suggestions. And I think the other thing that, we need to think about with especially given your pointing us to the Heckman papers, is thinking about what the true scale of X star actually is and what beta means. And then that relates into then the location and the scale of how you model the Z's in relation to X star. So that's something we definitely have to do a better job of thinking about. We didn't do it with the kind of theory stuff, and then we got to the simulations and we started to introduce it, and that's kind of a little awkward. But I'll just kind of leave it at that. Yeah.
So I've got a question about the use of dimension reduction, or I guess a couple of them. I'm worried about what if it's wrong, if the wrong assumption is that there's a single latent variable underlying this rather than the public health of accounting being multidimensional. And then I would think dimension reduction, not necessarily PCA, but maybe vectorization, would be most valuable when there's a lot of correlation across the components of that underlying model, the X stars in your, or the X's in your model.
So two things I'd say. So the first one I thought a little bit about in the sense, in some of the more recent simulations that we just redid, I did, even though the true data generating process was a single latent
Yeah.
X star, I did pull off more than just one component, and then I also played around with functional forms of the PCA index and the other indices as well to see if that added anything. In the simulations, they didn't.
Or
But here, the true process is there was a single latent one. So, yeah, I mean, I guess it just kind of gets back to this is a little bit of a structural setup. So, what do you think the true model is, and then proceed accordingly. So,
you might want to try a newer dimension reduction strategy than PCA.
and so I don't know what vectorization is. That'll have to.
PCA collapses different dimensions of the data to make it small.
Yeah.
It's not very thoughtful about what variance it throws out.
Yeah.
You're talking here about X as independent variables as indices. What about dependent variables as indices?
Yeah.
How would this be applied in that setting?
So right now that's in the conclusion for future work. There's actually a 2025 paper that just came out in Political Science. I think it was the American Journal of Political Science. And that's actually coincidentally the first place I had come across this reflexive versus formative, because they have that in their paper. But then I've seen it going back in papers 30, 40 years. But their paper is about when it's the dependent variable. And it's very much in the causal inference, so they're interested in the binary effect of a treatment on a latent outcome. And I don't remember exactly what they do, but they end up deriving a new parameter that's also a late, but it's a latent average treatment effect rather than a local average treatment effect. So anyway, there is a little bit of literature that's out there that does deal with it as the dependent variable. We were focused on the right-hand side just to start for this paper. And the Heckman stuff is also interesting because because it's a dynamic process for skill formation, then it's a dynamic thing. So the latent variable is on the left-hand side and the right-hand side because my skill in T+1 depends on my skill in T, and so they have both sides.
So related to the question about there being multiple latent variables, so what I've done in a lot of papers is do factor analysis, where I rotate the factors till I get something that looks interpretable, and then say, okay, well, this looks like mental health, this looks like mobility, this looks like, and throw in 4 factors or something. Have you thought about?
Yeah. I mean, at this point, I would say, yeah, we should think about it more. Here, we were just kind of doing it mechanically. We do have one factor analysis method that's also in there besides PCA. But that kind of detail, since we're looking across the board, we didn't get that focused in looking at any one particular one like that to try and look for an interpretation or anything. But yeah, I realize that's what people do.
I'll send you a couple.
Okay.
So now I'm thinking about this is like a more conceptual question. Like, so if you think of all the relationships to measurement error than highlighting here, it's easier for me to think of the setup where you've got income, which we know we have an objective measure for in some data, and in the survey someone misreports their income, and the goal there is to say you're using some mismeasured version of it, and so kind of you can't do that, and we're going to find something else you want to do. So I don't know if this is in the goalpost, but when you come here, you think of an underlying data and variable, which we know there's no data that is ever going to allow you to observe X star. Right? So in principle, if you set this up this way and you look at all these methods in PCA, I'm not surprised that things are going to just be bad, and given your setup of the model, then of course, nobody can ever know extents of all the things you do here. In principle, if I want to apply this, what if someone is the question of interpretation, right? Go, I want a function of health, or that depends on these things and how it relates to this. And then at that point, you are less worried about, oh, it's an interpretation question. This is a index of something being, and then I'm related it to an outcome. And then is your criticism going to be then smaller criticism in that case, which is like, yeah, this is an index. You might think it, proxies something or not. You might, whatever you think of it, then at that point it becomes an interpretation of the reader of your work to say, this is how this index correlates with this outcome. Sure. And at that point, it's about what you make of it instead of whether it's right or wrong. So, I don't know if you have any response to this.
No, I do. I totally agree with your point. And I think if people wrote papers that way, it would be totally fine. I think the problem is, again, this goes back to my rant, and my other related rant, I guess, as a tangent, is just we throw around the word proxy all the time. I think because it sounds fancy. To me, it just means you have a measurement error problem, but you don't want to say you have a measurement error problem. So the problem is, I think, we say like, oh, I'm interested in the effects of social capital, here's my index. And then the rest of you may caveat it like, oh, this is what it is, and it may not be a perfect measure of social capital. All the rest of the paper says social capital, here's the effect of social capital, this is how important it is or unimportant it is. People don't say, here's the effect of my index. What do I learn from this index? But I do completely agree, like, if you redefine it as what's the effect of X instead of what's the effect of X star, then there is no measurement error problem by definition. But people don't want to interpret the results that way. Yeah.
So I'm just going to kind of take you back to Michael's point, and so not only is Heckman jumping up and down apoplectic kind of with most of this stuff, but that there's a kind of a whole structural equation modeling literature which sets up a very nice unified conceptual framework, right? I mean, there are issues about kind of what assumptions you make, parametric assumptions, but both sort of latent on the right-hand side, latent on the left-hand side, measurement models, all of that is all kind of worked out. Mm-hmm. Economists don't like it, perhaps. I always kind of, when I read that Heckman paper first, I said, oh, he just reinvented an old wheel. Okay, I'm not saying that anywhere near the vicinity, but that's what it was, right? It's in many ways that structural equation stuff is there. It's scanned. People in psychology use it all the time, where these kind of multiple indicators stuff is very prevalent. So I guess I'd like you to push in that direction, perhaps, right? I mean, just because people do, people add up things and people whatever, doesn't mean kind of that's what we want to say, which one of those is better. I think there might be something better that we should think about. The health example is a great one, right? We do have a story about health. And maybe it's two dimensions of health, physical health and mental health. And then we don't know what that is. We have many, many measures that are kind of called proxies, I guess.
Yes, I agree. I've kind of avoided reading the SEM stuff in detail. My a little bit of uninformed approach to it is it's sort of like related to DAGs, and I'm not really a big DAG fan either. I prefer to think of the way my brain works in terms of the econometrics is I like to see the equations and then think about what's correlated with what, and so then when we do OLS or whatever, like what are the implications? So I mean, again, without being an expert on it, I would think like that's equivalent to the SEM approach. I'm just not writing it down as a picture. I'm writing it down in terms of equations and then thinking about what assumptions I'm willing to make and not make. I think too often when people draw DAGs and things like that, or the pictures, like the assumptions don't necessarily jump out as much, and stuff becomes more hidden, and it's a little bit, at least for me, harder to think about what the implications are. But yeah.
We'll then let Mike take the last point, and then we'll get some coffee.
Why are we just saying Heckman? Why aren't we referencing Jorskog and Sogor?
Because we don't want to receive an email later.
Yeah, right.
Because his picture
But, you
was
know,
up there.
even Heckman, at least he used to cite them, you know? I guess what Heckman did was put dynamics in the latent indices.
Yeah.
That was the, but the general framework is this Lizerl still. You know?
Yeah, yeah, and these mimic models that I actually did in my dissertation, everything comes full circle.
Great, thank you.
Thank you.